See, this is the moment. Oh yeah, there we are. So welcome to the session. We have 25 minutes and 98 slides. So I'm going to quickly go through a lot of stuff. My name is Johan. I'm a chief evangelist at ITQ. I love tech and I kind of love talking about it even more. We're going to talk about cost-effective home labs for AI workloads, something I've been really passionate about in the last 10 years. And when I think about home lab, and who has watched the GTC keynote earlier this year, NVIDIA GTC, like their flagship event. I see Garrett waving, but the flagship event of NVIDIA, where they announced this new thing, the Blackwell's GPU, 160 gigs of frame buffer, consumes roughly around 500 watts of power, does a gazillion million teraflops. It's just really, really powerful. And what they also announced was the Blackwell SuperPod, capable of running any type of workload, large models, large everything. And the question is, will this all run, like if you see all of those announcements with all of the really cool things they showed, and want to play around with that, how would you do that? Because I don't have the money to pull that off. I don't have the power, the utilities at home to pull that off. And it doesn't have a Wi-Fi acceptance factor. So I'm pretty sure if I turn this thing on, it generates more noise than, I don't know, the average vacuum cleaner or maybe 10 of them. Another thing they announced was the NVIDIA Inference Microservices. Anyone heard about that? Also really cool to run in a home lab. But will it all run in a home lab? So I'm going to debunk a couple of things. I'm going to talk about some of these workloads, but this is not going to be your average AI session. So who has participated in an AI session so far? Which of those sessions, was there a session that did not talk about Gen AI? So no Gen AI, something completely different than Gen AI. Good. This is going to be the first one. So the question is not, will this run? It will run. The question is, how will it run? How will AI workloads run in a home lab? And the title said, I'm going to talk about cost-effective home labs. That's exactly what we're going to dive into. So obviously, it all depends. Who knows this guy? Mark Hubbard. Right, so the amount of money he spent on a home lab was $186,000. That's not a home lab. That's probably a bigger infrastructure that most SMBs nowadays have. But he calls himself the home lab king. This was in 23, by the way. Pretty sure he upped his game and built out the home lab as well. But yeah, again, does not have a Wi-Fi acceptance factor. So we're going to do some myth busting because I believe that the cheapest, smallest home lab should be able to run AI workloads as well. So when talking about workloads, specifically AI workloads, we can talk about a few of them. Obviously, nowadays we'll look at like text recognition, conversational AI is something that we see a lot. Machine learning, traditional machine learning is something that we see at customers a lot. But the thing I like to play the most with are conversational AI and my personal favorite, computer vision. So let's talk briefly about conversational AI. I started a personal project a while ago called Project Kobe. I needed a cool abbreviation, so hence Kobe. But basically this was just my first attempt of building a chatbot and feeding information into that chatbot. So in the first version, I used a GPT-3 model, a LangChain-based application, trained it with VMware documentation and my own 2 books, and it runs in my lab without GPUs. Better yet, it runs on a Synology. So let me show you how that runs on a Synology. So the only thing you need to do here is add an OpenAI API key. And then basically ask a question, who is Johan van Amersfoort? And based on the information it trained on my own books, he says, I am the author of the VDI design guide and a Dutch end-use computing architect working at ITQ consultancy. So blah, 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 blah. I'll ask it, is it the year of VDI? And it'll come up with a really, really, really long answer. And I'll speed up a little bit, but at the end, the answer was basically, no, it's not the year of VDI, nor will it ever be the year of VDI. If you want to play around with this application yourself, the Kobe application, you can do so on Hugging Face. Who's familiar with Hugging Face? Who's played around with Hugging Face? Okay, this is really cool. So what you can do with Hugging Face, it's basically an application repository compared a little bit to GitHub, where you can find open source models, open source applications, all sorts of like really cool things, use cases. And let me show you a demo. So this is the Hugging Face space for Kobe. And is it running? Now it's running. What's really cool is that this is hosted at Hugging Face at no cost at all. So you basically see attributes like you would see in GitHub as well. And what I can do is, first of all, run it with any instance that is capable of running Docker images, in this case my Synology. I can find the Docker command there. But another cool thing is that it runs hosted at Hugging Face with 2 vCPUs and 16 gigs of RAM, which is allocated to my application. I can simply, if I want, upgrade it to a T4, a GPU, for 60 cents an hour, if you want to play around with GPUs. And this is the same application, but in this case, running at Hugging Face, again, at no cost. So if I want to play around with in this case, Gen AI, it's fairly simple to do so through Hugging Face. And if you want to play around with this specific application, create a fork out of it, play around with it with yourself, maybe customize it a little bit. That's the way you find it. It's nowadays called Einstein, simply because I added some more functionality to it, and we kind of rebranded it to an official project, which is called Project Einstein. If you want to know more about Einstein, I presented this morning a session with Frank Denneman on building service deliverables using VMware Private AI Foundation with NVIDIA. Check back the recording. We'll dive into like the architecture, how we build it, what challenges we faced, and what result we gained. But yeah, that's all about conversational I am gonna chat about, because I love computer vision. I love everything that has to do with computer vision. And to give you a little bit an idea of why I love it and how I use it in my own private life, I want to introduce you to Lola. So Lola is the neighbor's cat. It's a freaking huge Maine Coon. Who knows what a Maine Coon is? Right. If you don't know, it's the biggest domestic cat in the world. This thing is a kitten. Weighs 14 kilos. Its turds are bigger than mine. It shits in my garden. So this project is not finished yet, but I'm gonna show you what I did to try to avoid Lola to shit in my garden. So the objective was to avoid turds in my garden, use AI to detect Lola, master the art of Kubernetes, and learn about platform engineering. When I was explaining all of this at a different show I was presenting, I got feedback at this slide. You could have bought a dog. I could have bought a dog. What's the fun in that? So, I wanted to avoid a war with the neighbors while still being kind of animal friendly and doing something a nerd would do. So, another thing I wanted to do is debunk this meme. When I talk about AI, pretty much always use this meme. And I want to debug that. So, the requirements to do this was obviously no Blackwell SuperPod. I needed to have a low-cost solution, low power consumption, resilient. I'm already kind of spilling the beans here, but I needed to have it fully automated. Kid-proof. I have 2 small children, so couldn't put like 220 volts in the garden. That would definitely would not have been safe. And I kind of figured out a game plan. So, Lola, I invested in second-hand Ubiquiti cameras. Those are really good because they output a raw RTSP feed, which you can basically do whatever you want with. And I used something we call NVIDIA DeepStream. So DeepStream is a free-to-use SDK, which you can just download at the NVIDIA site and use the SDK not just to detect things in a video feed, but also automate stuff. So there are different steps in the DeepStream pipeline. So DeepStream, as soon as you implement it, you get a pipeline. And it's quite simple to adjust some of the steps in the pipeline and trigger events. So, first thing is as soon as the cameras detect Lola, the DeepStream pipeline will trigger something, a solution called Scripted. And Scripted lets you basically take an RTSP raw video stream and output it to basically any type of device. In my case, Google Home displays. Second thing that's triggered as soon as the inference engine detects Lola is a solution called Homey. Who's aware of Homey? Oh, nice, couple of hands. So it's kind of a commercial competitor to Home Assistant. And it has all sorts of sensors in the solution itself, and it basically is an automation engine you can trigger certain devices in your house with. In this case, as soon as Scripted detects or sends the RTSP stream through to the Google device, Homey sends out a push notification as well. And the next thing that happens is my watering system is being triggered, which will end up in a shower for the cat. Well, this sounded like an awesome game plan. So this was the whole idea, like kind of the design. Now I needed to build that. So step 1 is to actually build the application. And what's really cool is that DeepStream is a free SDK, but it's also used at one of our biggest customers who does recognition of certain aspects in a video stream which are relatively privacy sensitive. So I'm not allowed to talk about it, but on a very large scale, some companies are detecting information in public cameras that are available. Let's call it like that. So it is a really enterprise-grade solution, and kind of looks like this. And the really cool thing is, within the different steps within the pipeline, you have different kind of accelerators you could use to accelerate certain aspects of that pipeline, which is really cool. And I'll show that in a demo. The way to get it is also very cool. So this morning, you may have, a show of hands, NIM, NVIDIA NIM, was familiar? Good, so this is the NGC portal, NVIDIA GPU Cloud. And what you basically can do here is, like you would do with Hugging Face, download in this case, a Docker image that contains everything that DeepStream needs. So it has DeepStream, but all of the SDKs, the drivers, the middleware you need basically to run it, just by going to ngc.nvidia.com. Now, there is and I'll share the slides later on, by the way. There are a couple of different containers based on the type of device you want to run it on. And in my case, that's basically the one for Jetson Nano. So the Jetson Nano is kind of a Raspberry Pi on steroids. It has 4 gigs of memory. It has a gig Ethernet, 128 CUDA cores, so GPU cores, and it fully runs Ubuntu, and it's really cool because there's a prepackaged image for that in which you can run deep stream on it. Who has ever worked with Jupyter Notebook? Okay, cool, couple of hands. So Jupyter Notebook is something that's pre-packaged with that image. And it's basically an IDE for developers to talk to stuff that's running inside the container, in case my application, but they also have access to the console within the Docker container. And in real time, you can adjust the code and see what the result is. So the way an AI practitioner quite often works is not by building code, putting it in production and wait until the code is being pulled in production, but they want to see on a real-time basis what happens when they adjust the script or adjust certain parameters in a model whatsoever. They want to see directly what's happening there. And Jupyter Notebook is a great way of doing that. So what I'm going to show you is the actual demo. So what you can see here is the DeepStream SDK, and I'm pulling in my RTSP stream at my home. And if I run, but just hitting the play button in a bit. Oh, I'm going to show a config first. These are all the individual config settings for the RTSP stream. And these are what we call labels of the data that it needs to recognize. And what I'm using here is a ResNet model. It's a relatively old model, pre-trained on using or on detecting certain objects. And what's really cool is that it does support Git integration. So if you build an application, Jupyter Notebook could just insert the, do a Git pull as soon as you update the application as well. So in my case, if I want to add additional labels or whatsoever to the application, it automatically syncs. Is the video still running? No, it's done. Okay, cool. Next one. So I had the application. I'm going to show it in a bit. Next thing is to build the infrastructure. So this does not fit in a home lab. This consumes hundreds of watts of power consumption, and it's really cool. It's an A100, but it doesn't fit. This does fit, kind of ish. Becomes cheaper. This is a Quadro RTX 6000, supports vGPU, has 24 gigs of frame buffer, but again, expensive-ish. This is also really cool. I got a question earlier today. What should I do with my old GeForce? Well, run deep learning workloads on it. It does support CUDA. It does support DeepStream. It does support all of the stuff to get started at 60 pounds. So that's relatively nothing. But what I wanted to do is run it on a Jetson machine. But one of the goals was to keep it resilient. So I built out a cluster of Jetson Nanos in a Lego rack. Who recognizes the vExpert NUC? It's cool. That's my main node. So it's the master node. So I got 2 Jetson Nanos, the vExpert NUC, a $35 Ubiquity switch, software, Ubuntu K3s. K3s is a lightweight version of Kubernetes, and Jetpack, which includes everything I showed in the earlier slide. So that's basically the operating system of Jetson. So the cost, relatively nothing. Well, it's still a bit of money, but under 400 euros, you can have a cluster running those workloads, resilient, at 30 watts. So it was from a wife acceptance factor, really good. Now, some specs, but I'm going to run through it. It includes Jetpack. So I mentioned Jetpack already, has all of the stuff you need to get started. It includes the container runtime, which you need to run your application, your GPU accelerated application, inside a Docker environment. So I needed to test out if that works. So again, I'm going to share the slides later on. Testing GPU support is really important. Result in this case is passed. Next thing to do is to implement Kubernetes. So I did have Docker installed, pre-installed on the Jetson nodes. I wanted Kubernetes to manage those nodes, which is K3s in this case. Next thing was to test out if K3s would support the application and see the GPUs. It does on both nodes, which is really cool. Next thing to do was to build a pod and see if the GPUs are still supported. which worked out as well. Final thing to do was to run TensorFlow, a deep learning framework used in DeepStream to detect objects in a video stream. Also worked, really good. And now to run the application on Kubernetes. So there's two things I know I shouldn't have been doing. One is that I shouldn't be using host networking, and the second one is definitely not to run allow root. But for the sake of this demo, I want to show you some things. So first of all, I'm going to show the RTSP stream, the raw one. Start DeepStream with the pipeline. We show the utilization of the Jetson node. I'm going to show the output in VLC. Really cool. So this is me in my garden, kind of waving. And now I'm going to start the actual application. So it takes a little bit of time. It's a Jetson. It's an ARM-based machine with 4 ARM cores. So it's not the fastest, but as soon as it starts, you can actually see that it is opening up the video stream, starting the pipeline, and in a bit, we will see the, yes. So this is a really cool tool, JTOP. So it basically shows the top information from a Jetson, including all of the GPU information. So here are the hardware engines with NVEnc, so the encoding, hardware encoding of the stream. You can see GPU utilization here, there. And if we go back to the application, you can actually see now that it's running. We'll open up the new feed, and you can see that a person is being detected, which is me. But you can see it's a little bit choppy. Okay, so this works. Next thing is to test it on a cat. My cat. There we go. There's a cat. Right, so that failed. Next thing was to teach the model how to recognize a cat. And I'm using YOLO for that. YOLO means you only look once. It's basically a deep learning framework that you can, with pre-trained models that you use to recognize basically anything. It's a lot faster than RCNN and ResNet. So you can already see it's less choppy because YOLO is much more lightweight. Cat ran away. Could happen. Well, it recognizes a person, but not a cat. So, again, objective was Lola, and I'm very persistent. So, I thought if it doesn't recognize my cat, it's maybe because it's not a Maine Coon. So, why not just take a picture of Lola? It recognized a chair, no cat. What if the background was an issue? So I took away the background. Nothing. Still, it recognizes a cat. Not my cat, not the cat of the neighbors, but it recognizes a cat. So this is kind of the preliminary conclusion. I failed so far. It does recognize cats, but just not the cat the objective was. So the next steps are to train a custom model on different cats, implement networking and load balancing to make this really like it should be, share everything on GitHub, which I will. Some valuable resources, and I got 60 seconds left. If you want to start your own AI journey, play around with DeepStream, play around with Gen AI, play around basically with anything, go to Launchpad. That's basically your hands-on labs by NVIDIA, and this environment is powerful enough to build basically anything and test anything. It's really, really good. And there's kind of a lab-based structure that you go through to learn about it. If you want to play around with this on your own environment because you bought a Jetson or you have a second-hand GeForce laying around or whatsoever, second thing is to go to, what you could do is go to the Deep Learning Institute. It is kind of their online university where you can pass exams and do all sorts of courses. And the course material is really good. You can, the thing I built for my solution, You can just download it with a complete course to go through all of the individual steps and play around with your own video stream. It's really good. Final thing, if you want to play around with K3S in a cluster, you could use that link. To conclude, a couple of key takeaways. Not every AI workloads require a GPU. Simple as that. If you want to play around with it, you can do that basically for free. Second thing, playing around doesn't require a home lab, but in case you want to do it and you want to accelerate, there are cheap options like a second-hand GeForce. And there's a ton of useful resources to start your own journey on AI. Some final considerations. Frame buffer is key to run more and complex workloads. If you want to know more about that, I'll be back here tomorrow to talk about our AI proof of concept service. And we tested around different models, all types of parameter sizes, from literally Llama 3.1 405B, which requires more GPU resources than probably any company in the Netherlands has, or like smaller ones, Gemma 2B, which can run on basically any GeForce. So we're going to talk about that tomorrow. Any GPU that supports CUDA 10.x will do, which is literally the GeForce I showed. So the 1060 Ti, which is already 10 years old, will support this. And Intel and Google also have accelerators, like the Google Coral, and Intel has a USB one that might work. So it's really cool. Any questions? I see you thinking. The cat is still alive. Yes, that is a good question. It's winter time, so it's not outside that much anymore. I will solve this in the spring of 2025. Any more questions? Gabri.
Wait. It's important.
So the Jetson is not a complete system. It's USB connected to the vExpert thing.
No, the Jetson is literally, it looks like a Raspberry Pi, but a little bit more powerful, and it has the GPU installed on it.
But what was the in your config? What was the vExpert?
Good question. So I use the vExpert node as my master node within my Kubernetes cluster, and the two Jetsons are two worker nodes. I ordered a new, like a Seed Studio kind of. It's a cluster housing for 4 Jetsons. So the Jetson consists out of a baseboard and a module, a Jetson module, and the module can be taken out. Is the size of a matchbox, and you can put it on a cluster board. So you have less. You need less Lego to build something like that. Any more questions? If so, I'll be walking around and happy to answer anything. Thanks so much. Have a great conference. Hopefully see you somewhere this week.